chemical storage. In this slide, I will talk more about, you know, how do you segregate the chemicals. I hope that will give you some input when you want to plan, you know, your inventory and how do you store your chemicals. So this is sometimes we observe in the lab. So again, you shouldn't put your chemicals in the ducted or ductless swimming pool. They are not meant for storing your chemicals. They are meant for handling your chemicals, right? So we also observe many people put liquid chemicals on the shelf like this as well, okay? So I will explain why you shouldn't put liquid on the open bench, right? So these are the, I tried to give you one reference method. There's more than one method of chemical segregation in the market. To be frank with you, in Malaysia, we do not have guidelines for laboratory chemical segregations. We have it for industry and waste storage. So, so most of the lab will follow either a Stanford method or, you know, your own method. So what I'm talking now is the Stanford method. So I want to share with you. I hope it will be beneficial. It's just for your reference. If you think it's good, you can adopt it for your lab. Okay, let's start with the powder and liquid chemical. We should segregate these two type of chemicals. So the chemical powder is basically you can arrange it alphabetically. Okay, you can A as a acetone example, etc. A, B, C, D. Okay, of course you have to segregate out the water reactive powders, the explosive powders, or those chemicals that are incompatible with all the rest of the chemical powders. In these three groups, you have to segregate and store differently, okay, at the separate cabinet. But for others, you can just put it on the rack or shelf and arrange it alphabetically. All right, that is for chemical powder. How about liquid chemicals? Liquid chemicals tend to be more dangerous because you will, even though you cover the lid, you tend to still have evaporation. All right, a small trace evaporation, especially the corrosive chemicals. You can still see the sign of a leakage. Right, so I will segregate them into two physical space, right? The first one is the chemical room. You should have a chemical room. For the chemical, we'll segregate to chemical room and the working laboratory, right? So because in chemical room, normally you will buy in large quantity because you have budgets, then you will buy to put into your inventory, right? So in that situations, we will recommend you to store in the flammable cabinet and also the acid cabinet. All right, so that is chemical room, right? For laboratory, normally you have multiple types of chemicals, but in a smaller quantity. It could be 1 liter or less. So you can put into a vented multi-risk storage cabinet. Let's talk about chemical room. If chemical room, the best way is to segregate your chemicals according to the type of chemicals using a cabinet. Okay, each type into individual cabinet. So I believe you are familiar with this cabinet. There's a color coding for each one. So the yellow normally for flammable chemicals, like those solvents that are easily flammable, that is yellow. Red colors, occasionally we'll find them. Red color is meant for combustible liquids like petroleums, like butadiene, like kerosene, etc. All those are for red color. And the blue color is for acids and base. All right, blue color for acid and base. Gray color or white color is for toxic. And the green color I never see in Malaysia is for insecticide and pesticides, right? So I want to highlight the blue color. The blue color, you will have two types of material. First type is the metal acid cabinet. Another type is a fully polypropylene plastic-like acid cabinet. You may ask at what situation I should consider a PP cabinet and in what situation I should consider a metal acid cabinet. Okay, this is my suggestion. If you have organic acid which is less acidic, you are okay to store it into a metal acid cabinet. Where else you have a strong acids or inorganic acid like HCl, sulfuric acid, nitric acids, I will recommend you, especially in large quantity like 4 liters, 2.5 liters, make sure you store them in a PP acid cabinet. Okay, so your cabinet can last longer, your chemical is safe. So there's a few things you need to consider when you store your chemicals in a cabinet in your chemical room. The first one is to have ventilation. European norm says that EN 14470-1 says that you need to have at least 10 air change per hour, okay, for your cabinet. So you can have a filtration box, or you can also install a duct system, okay. The second things that you need to consider, I think most of you have done so. If you're not, you should do it now, which is the secondary containment for your chemicals. Those that, even though it's compatible, but different group of the chemicals, you have to segregate it again using a secondary containment, which could be a tray, a spillage tray, or a PP box. A PP box is best for strong acids because you want to reduce the evaporation. This is an example of how do you segregate using a secondary containment. You arrange it correctly. And of course, some very toxic, very corrosive chemicals, I will also recommend you to put it into a PE bags. PE bags is also a secondary containment. Basically, you cover the whole bottles with a PE bags, right? So that is secondary containment. Now we go to the working room, which is the working lab, which is the lab that you handle all your experiment, the student teaching lab, etc. You should have something like this, which is the transparent door, and also you can segregate different chemicals on one single storage system, right, to save cost, right? So this publication I can email to you as well, free of charge. Is actually tell you how do you segregate when you put your chemicals in one the multi-risk transparent door storage systems like I showed you just now, right? So I want to quickly go through this, what it means by all this number to give you an idea, and I hope these ideas you can use it in your lab in terms of how do you store and segregate your chemicals. I want to highlight a few chemical group first. I want you to look at the X, all right, the B, and also the K, all right. I want you to look, even though it's a bit small, but sorry, but look at the B, boy, X, and K. These three groups is to be stored in separate cabinet, okay. Each one small compartment, you know, their own cabinet. B group is water reactive. K is an explosive. X is incompatible with all the rest of the chemicals. In this three group, you should segregate separately. The rest you can put into the single storage cabinet. Okay, so I want to highlight G and L to you. G is the non-intrinsic, the reactive, flammables and combustibles, could be like your pH buffer and etc. L is solvent, right? Solvent, right? So you can see here, and then I want you to look at ADCF. ADCF, okay? A is basically organic base. D is organic acids. C is inorganic base. F is inorganic acids. I hope you got the concept already, which means you segregate all the corrosive at one side, but start with organic. When you go down, go for inorganic, because inorganic is more corrosive. All right. Then the last one is the E. E is basically the oxidizer. So you basically separate it from the acid, okay, and of course also the solvent. How do you be able to install all these ABCD, ACDE group into one cabinet? You can do so by doing this, because if you look at the the storage, it has 4 compartments and each one has 1 door. Okay, so you can basically put your corrosive at 1 column for the 1 door, and your oxidizer and you know, your solvent at 1, and etc. Right? So I want to show you one actual one of my customers that they did it perfectly. Right? This is from UTP, University Technology Petronas. You can see that they put the L and G, which is the solvent, and the non-intrinsic reactive solutions in the chiller, and sometimes also in the storage cabinet as well. And the rest, you can see that they put it properly, like DF, CE, and etc. Right? So, of course, you can also, they also use it for other application. Right? So this is the flavoring companies. Basically, they are not concerned with chemicals, they're concerned with smell. So we put up the filter system for them. This is the storage that I mentioned before, the chemical room. So they have a filtration box. Why filtration box is more practical? Because you can only install ducted when the building is new. So if you have additional flammable cabinets coming in, the best way, the most economical way is to have a filtration box. All right. So, and more. Yes, okay. So thanks for your patience. I think my presentation will end here, and I welcome your questions. And the link for the demonstration by Mr. Julian will be sent to you separately by email. So do spend some time to look at the options of filtration system available from erlab that you can consider when you need to tackle, you know, the vapor issues or risk issues in your lab.